The graph of a function is a curve in the xy plane. But the question arises, which curves in the xy plane are graphs of functions? This is answered by the following test, and it's called the vertical line test. The vertical line states that a curve in the xy plane is the graph of a function of x if and only if no vertical line intersects the curve more than once. Now, the reason for the truth of the vertical line test can be seen in figure 13. If each vertical line, x is equal to a, intersects a curve only once at the value of ab, then exactly one functional value is defined by f of a, which is equal to b. But if a line x equals a intersects the curve twice at a and b, and a and c, then the curve can't represent a function because a function can assign two different values of a. So that means that this graph on our left is a function, and the graph on the right is not a function because it doesn't pass the vertical line test. Now, for example, the parabola x equals y squared minus 2 is shown in figure 14a, which is right here. Now, it is not the graph of a function of x because, as you can see, there are vertical lines that intersect the parabola twice. Now, the parabola, however, does contain the graphs of two functions of x. Notice that the equation x equals y squared minus 2 implies y squared equals x plus 2. So what do they mean by that? That means that if we solve the equation x equals y squared minus 2 for y, then we would add 2 to both sides. So we would get y squared. And then we take the square root of both sides. And now remember, when you take the square root of both sides, it's a plus or a minus. So now, what do we have to square to get y? Well, we know it's going to be y. So we have plus or minus the square root of x plus 2. And that's equal to y. So I'm going to show you this graph. And this is called Desmos. So you'll see this quite often in this class. It's a great online graphing calculator for free. But here is the graph that we first put in, which was x equals y squared minus 2. And as you can see here, it does not pass the vertical line test because it passes through more than one point. Okay, so we know that this gives us two solutions. The two solutions are positive and negative square root of x plus 2. So we have a negative square root of x plus 2, and then we have a positive square root of x plus 2. So that means this is equal to y, and this is equal to y. So what can we do here? Well, if we go back up to what they were stating in here, okay, this is how we get plus or minus the square root of x plus 2. Thus, the upper and lower halves of the parabola are the graphs of a function, f of x equals the square root of x plus 2, and g of x is equal to the negative square root of x plus 2, because what happens here is that it cuts off one half of the parabola. So if we take a look at this example here, okay, let's take a look. We have, we're going to put in the square root of positive square root of x plus 2. Now you can see that it graphs the top half. And so I'm going to go ahead and delete the first graph so you can see the only part of this graph there is that. So now what we want to do is we want to graph the negative of this, which gives us x plus 2, and you can see that the bottom half now works. So now what I can do is, if I Now take that half off the parabola. Now this passes the vertical line test. So we could have eliminated one or the other side, and that's by using a restriction. So we observed that if we reverse the roles of x and y, then the equation x equals h of y equals y squared minus 2 does define x as a function of y, with y as the independent variable and x as a dependent variable, and the parabola now appears as the graph of the function of h. So in this case here, you can see what happens for us to determine when a function, a graph is a function by using the vertical line test.